Good day, everyone. My name is Lawrence Economo, and today I will be discussing my laboratory number activity number 5, combined time signal and amplitude transformation of the digital signal. So let's proceed to the code. Here's our first we import the NumPy as NP for numerical operations and matplotlib for plotting. Now, now we create the time index n using np.arrange -10, 11, 1. So this generates the time sample from -10 to +10, giving us 21 sample points total, including negative indices allow to see how the signal behave before time zero. This is crucial for understanding casual and uncasual system. Then we generate our test signal. X is equal to np dot sine 0.3 dot np dot pi times n. So now we plot the original signal with negative indices. So we use PLT.stem with black baseline is NX then base of MTK. And now we plot the title, original title, the X label, and samples, then Y label amplitude, then PLT grid, and we use PLT show to show the. So then now we go for our amplitude operation. So now we for now we use X amp shift is equal to 2 times n to the sine 0.3 n to the pi n minus 3. So this doubled every sample value at every time index, including negative ones. Second is the attenuated. So x at rev is equal to 0.5. So this halves each sample. Then third is x inverted, which is x in scale is equal to -1 times n to the sine. So this multiplies by the -1, flipping the signal polarity. Now, we now plot the we now setting up the subplot figure. So we use PLT figure, figure size 12:8. Then we use PLT subplot 311 to select the first of three vertically stacked subplots. So the we use first subplot we plot the amplified signal, the factor of 2 means the sine wave peaks now reach amplitude 2 instead of 1. Notice this applies equally to sample at negative and positive time indices. The stem plot shows the increased magnitude clearly from n equals -10 all the way to +10. So now we use subplot 311, PLT that stem, and X amp sheet base FNT. So this is black. Then we put the title, PLT amplified plus time shift signal, so PLT X label N, and put the Y level amplitude, and PLT that feed through. So now for the second plot that showed the attenuated signal with factor zero point 0.5. These peaks only reach zero point 0.5 amplitude. This represents making a signal quieter, having a full range from -10 to +10. Help us see the attenuation is uniform across all time. It doesn't matter if the sample occurs before or after zero. So now we use the PLT subplot 312. So this one is in the middle part. So PLT stem and X at red base FMT. So this is black. Then to the title, attenuated this time reverse signal, then we put the X label and Y label amplitude and PSD grid 2. And the last, and for the third subplot, so PLT that subplot 313. So it's the bottom part. So the third subplot shows the inverted signal multiplying by -1 flips every signal sample signs, positive values become negative and negative becomes positive. Notice how the wave shape is identical to the original but mirrored across the zero axis. The negative time sample also get inverted. The symmetry is preserved across all time. Now, so layout display. So PLT the title layout automatically adjusts spacing between three subplots. So title and labels don't overlap. Then PLT that show display all three plots stacked vertically. So easy comparison with the x-axis minus the -10. So to +10. Now we run the code. So here is the original signal. So as you can see, this is a sine wave from the original wave. Then So here is the amplified. First is in the amplified. So original wave, from original wave that peak to 2. Now we see, I from that peaks on 1. Now the the amplified signal peaks at 2. And so see here. Then the second one is the attenuated. So from the original signal that peaks on 1, as you can see, this one peaks at zero point 0.5. And the last one is the inverted time signal, which is, so it is just like a mirror of the original signal. So that's all. Thank you.